with 5 seats in each row. So it's like a row seat here, 5 seats here, like this, and it goes on till 20, right? So then we are given a seat position X. We are given some seat X, and two people, chef and chefina, are sitting at X and X plus one positions. So we need to say that will they able to talk to each other? It's very simple that they only talk to each other when they are sitting side by side, right? Isn't it? So what did you say?
In a particular row there are only 5 seats, so if they have to be seated side by side, only not be a multiple of 5, then only they could be seated together, so that was pretty easy.
Be able to talk with X plus one, and this only happens when it's a multiple of 5. So this was a pretty simple question, that if we check X mod 5 is true, then we just, it means true, that is it equal to 0. Then we see out no, else yes. We don't have to check for any boundary conditions like so we don't have to check that condition too. It's pretty simple. You can look at the code here. There's not much to do, but still. So if n mod 5 is equal to 0, we see out no. Rather, if it's not modulo 5, then we see out yes, right?
Yes, we.
So yes. So the another next question, that is B, that there's a tournament. I will discuss the question for now, right? And if you feel like giving the answer beforehand, you can just say. So there is a tournament going on where there are two contestants, A and B. Both have their names as given, right? So on the tournament card, their name in starting common letter. So if it's Rahul and it's Rohan, then we know that before of the tournament, because if we print other letters, then it would cause a problem, right? So it's already given to us that the first letter is always the same in the question, and there can be the further letters can be also same in that case, right? So we need to say, we need to print as many as letters possible. So what do I mean? That let's check the sample test case here. Like it's Alice and Alonso. So Alice and Alonso have AL in common. So this AL is common here. The question is pretty straightforward. Depends on how we answer it. There are multiple codes in general. What did you do, Arnav, in this one?
I just made two character arrays and checked if how from the starting of the array till how much till when both of them have the similar characters, and the point where they don't have similar, I break the loop and print out whatever was printed.
Okay, right. So this is pretty simple. That's what I also did. So we took in two strings, right? A and B. So between the strings, minimum of their length. Think of Alice and Alonso. So this is 5 and 6. These are the lengths, right? So whatever the length will be printed on the tournament cup, that will be the minimum among these two. So it will be at max 5. So we run a loop in A and B from 0 to 5 here for that case, or the minimum among length of n and m, and check whether if those two are the same, that is a of I, both characters are same, then we see out this character. Then we print it simply. And if they are not equal, then we break. Right. This one is also pretty simple, but it can confuse a few if they don't get the question right. So we are just checking till the minimum of n and m, and then we are incrementing the loop until and unless they are equal. We keep printing that character at that place. If they are equal, we just break the statement and return a new line. So it's simple rather. Okay, let's move on to the third question of diff 4. So this question is a better one at least. So draft picks. So Arnav, you read the question, right? What did you understand from it? First, you tell me what you understood, and I will explain the question itself.
The question tells that you will be given some numbers n and k till number of cards, and those cards will be from 1 to k, and exactly one card will be there of that number, and we have to pick the highest number, the card with the highest strength, and go in a ascending order of arrays, like first we'll give to first one, second highest card to second one, and when the number of people ends, we need to reverse the order, and keep reversing the order till all the cards are finished.
Yes, right. So what we are doing, we have k cards and n people, right? It's not necessary that k will be greater than n or something. So we have n people, 1, 2, 3, 4, let's consider till n. So what do? We distribute the highest card k to the first person we look. So one gets kth card, means kth card has power of k, right? Second gets k minus 1. Third also gets k minus 2, like this it goes on. N gets k minus n minus 1, right? So this is what we are getting. And then after, if the cards are not finished, then we reverse this loop. Then n gets the first card, that is k minus n minus 2, and it goes on till like here, correct? So we need to find what is the maximum power a index can have, right? So what did you do here, Arnab?
Uh, I ran through two if conditions. First one, I checked whether I is a loop of I where it is divisible by 2 or not, uh, and multiplied I with the number of people. So when let's say I is 0, so loop runs through only n people, like 0, 1, 2, 3. So it goes in one way. When I becomes 1, like n times 1, we have 3 people. Now we go through 4, 5, 6. When it was 0, it goes through 1, 2, 3. Now 3 times 1, 3, 4, 5, 6. Now again, it will go I star 2. Then every time it's a multiple of 2 I, it will uh, give the number from ascending order, and when I is a multiple of 1, it will give it in the descending order.
So you are also meaning that when we are doing this, we are giving I modulo and the value, isn't it?
Yeah, yeah, yeah.
Yeah. So if we are going like you said, 1, 2, 3, then we are giving the left maximum if for 3 is the case, and 4, 5, 6 Then we go, if we are going right here, then we go left here, isn't it?
Yes, yes, yes.
So we are also, if this is increasing, then we need to keep a modulo 3 check also. Means as 3 here is, so we need to check a modulo n. That's what you meant,
Yes.
right? So that's also a possible case. It's pretty simple with that. We can also have a simple brute force here. Your the logic you had is the same as this one. So what do? We have a vector which is v of n plus 1. Why we are taking plus 1? Just to keep one based indexing. We're not going a whole lot on just checking out the index and all. So v of n plus 1 means v of 0 is 0, right? Then we are taking in from I is equal to 1, we are having all the values in that one index. And till k is greater than 0, that is, we have some cards left. We put all the 1, then 2, then 3, till it is less than n, right? We keep putting in the vector till it's less than n. Okay? But once n is filled, that is, we reach our n and I is greater than n, we have a pointed decrement that how many times we have run in the loop, which is a c. So at first we had c equal to 1. So what did that mean? Like c is equal to 1 meant nothing but we have traversed the array for once. And if c is 1, that is c is odd. So we know that we need to go in this right direction, and else we increment the c to 2 when we go in left direction, right? So what we were doing here, we were doing here I plus plus. If it's greater than n, we will do here I minus minus, right? It's the same what you said. It's just a little bit different fashion, right? So we are going here c minus minus means, sorry, we are going here c plus plus, right? So if c is equal to 2, we go left, else we go right. C is equal to 1. When we hit again a 0 here, we decrement the C to 1 rather. Okay. And we have one based index. So here check that we are doing this I plus 1, right? Means I if less than 1, then we decrement our k. And for that means we have a vector stored from 1 to n, which contains all the values possible with that card k. And so we can always find our maximum element by simply traversing through the vector. This was your, what do we say, approach to, right? And
Yes, bhaiya.
in similar sense, but you use a straightforward for loop, right? And kept flipping it until and unless you got your left and right. So I was doing it manually, but you used a, what do we say, mod 2 operator or something,
Yes,
right?
bhaiya.
Okay, so we have covered ABC, and now we'll move on to for diff for D and E. Those will be taken by Shomujit Bhaiya. So, okay. And if you have any doubts till now, you can ask me.
I hope my screen is visible. Right? Am I audible?
Yes,
Am I
bhaiya.
audible?
Yes, bhaiya. Yes.
What about others? I think what's your name,
Yes,
Nebula?
Bhaiya.
Whatever, Cyan. Cyan is inaudible. Fine. Okay, how many of you solved this eventually equal question? Eventually equal. Arnav has done okay. Alok, Nebula, Cyan has also done. Right. Okay. Once I explain the problem statement, then I will come to you one by one. You're listening to your approaches. So we are basically given three integers a, b, and c, and our goal is to like make them equal, a and b, and at a time we can apply two types of operation. Type one is that we can replace a equal to GCD of a comma b, and second we can do is increment c by 1. Okay, and then we have to make sure that we make these equal. Okay, I hope the problem statement is very clear. The question, okay, simultaneously replace a by GCD of a comma c, and also b equal not a comma b, it will be a comma c, and b equal to GCD of b comma c, like that. So, and or increment c by 1. So what were your approaches to this question? Any observation? Any greedy approach you can share? Alok, Arnav, Nebula.
Bhaiya, I was thinking it
Hmm.
would be done in 20 to 30 steps maximum,
Okay.
something like that.
Why do you think so? It can be solved in a finite number of steps.
Because if we cannot repeatedly take GCD, and if we increment, we will encounter any prime number very soon.
Yeah, right. Okay.
And
What if my prime number is very far? So in that way, you're thinking, no?
yes, I think in that order, prime number will be encountered within 20 to 30 steps. Like there is such kind of interval.
Okay. So you're saying for any number, its next prime is basically 20 or 30 steps away.
Yeah, yes, maximum.
Okay. What about others? So you're saying that the maximum answer can be from less than equal to what you're saying 20 to 30 steps, no? Answer. Okay. And what about others? And now we have solved this, I think. Hello.
Yes, Bhaiya. Uh, I took the approach that if A is already equal to B, we need not to do. When A is not equal to B, we will first check whether GCD is equal to not. If it is not equal, then we go to the steps that we have to follow, where I ran a while loop till GCD A comma C is equal not equal to GCD B comma C, and incremented C by 1 and changed A to GCD A comma C and B to GCD B comma C.
So from up to when you will your while loop will run, like
It will run till about we encounter C as a prime number, and plus if A and B are pretty large numbers also, C will get them down to pretty low because A is changing to GCD A comma C and B is changing to GCD B comma C.
is it necessary? Okay, fine. What will be your like the maximum answer can be? Is there any limit to your answer? Like how many steps?
That I cannot tell. That I cannot tell.
Okay. So I think you tried to make okay. So you are all of you are getting that okay. At one time I'll get the C as a prime by next prime, and I'll get eventually my answer. I think finite number of steps. No. Okay. Here we'll prove that it can be done at max 3 operation. Okay. And you are I think thinking in the same way, but one thing you're missing, that another thing, that is co-prime, no? Co-prime. Okay. Before that, tell me what is the GCD of any C comma C plus one?
One.
One. They are co-prime, no? Okay.
Yes.
Okay. Let us do reverse thinking. If GCD of this and this are this, what will be the GCD of any A comma C plus one? Where A is an integer, positive integer. Will it be one?
Till one.
Again one for any integer?
Yes.
So I can write like this: GCD of, okay, whatever the given A and B. I hope the I think the when should equal A and B are positive given in the question. Yeah, A and B are all are positive. So for any positive, I can write like this: now GCD of A comma C plus one is equal to GCD of B C plus one is equal to 1. Can I write this?
Yes, Bhaiya.
Okay. Another reverse thing. Okay. Tell me one thing. GCD of A comma C plus 1. Can I write like this? GCD of GCD of A comma C plus 1. Can this be written in like this? Okay. If you don't know, yeah, it is right. Right. So
Yes,
whatever
Bhaiya.
the GCD of G, and okay. From this, can I also write like this is GCD of GCD of B comma C plus 1, right? Both are equal to 1, right?
Yes, Bhaiya.
So irrespective, okay, I don't know what are the values of A, B, and C. I'm just doing the steps. So step 1, I will do the type 1 operation, changing A to GCD of A comma C, and changing B to GCD of B comma C. Okay, then what I will do in step 2, I will increment C by C plus 1, and in step 3, and again do the type 1 operation, applying GCD of this. Now C prime has become this. So my A would be GCD of, okay, so these are all A prime. I've applied the operation. So A double prime would be GCD of A prime comma C prime, and B prime would be GCD of, I think, B prime comma C prime, and both are equal to 1, no? Right? Do you all agree?
Yes, Bhaiya.
Right, A prime is GCD of A. Okay, Nebula. So basically, you will see that at max, how many steps are required now? Using the concept of co-prime, GCD of C, comma. At max, I need 3 operations. Right? Is it understandable? Okay, Nebula. Arnav?
Yes, Bhaiya. Yes,
Yes.
Bhaiya.
Okay. So I my answer would be at max 3 if I write brute force at worst case. Okay, and in the question also you will see answer are basically 0, 1, 3, 2. So at max the answer is 2. Okay, if you understand this, okay, now we have to ensure, okay, when our answer will be 0, when our answer will be 1, and when our answer will be right? Okay, when our answer will be 1, uh, obviously when A equal to B. Okay, I think in the sample disk is given 1, 5, 5, 12, A, B, C. The answer will be 1, 0. No operation required, already they are equal. Okay, now when will our answer be 1? For example, if I take the sample test case, I think 7, 6, 13, right? 7, 6, 13, A, B, C. And our answer will be 1 when when applying the type 1 operation only. You can see GCD of A comma C is equal to GCD of B comma C equal to 1. Okay. 7, 13 are co-prime, 6, 13 are co-prime, and answer will be 1. Thus applying the type 1 operation. Right. So this will be when A is not equal to B, but GCD of A comma C is equal to GCD of B comma C. Right. So number of answer would be 1 in this case. Right. Nebula and Arnav and whoever is present, Alok,
Yes, Bhaiya.
Sayan, right? Okay. And when our answer will be 3, okay. So yes, my A is not equal to B, and my GCD of A comma C is not equal to B, GCD of B comma C, but but my GCD of A comma C plus 1 is equal to GCD of B comma C plus 1, right? For example, in the, I think A equal to 7 was there, B equal to 6, and I think C was equal to 22, right? In this case, A is not equal to B, right? And GCD of 7 comma 22 is 1, and their GCD is 2, right? If I'm right, yeah. But their GCD of 22 plus 1, that is 23, and GCD of 622 plus 1, 6 comma 23 is equal to 1. So the two steps will be first increment C by C plus 1 and then apply those GCD operation. In this case, my answer would be 2. Right? Is it clear? Okay. And in all rest cases, my answer would be basically 3. Right? Else. So we'll quickly move on to the code. Okay, so eventually I also got this. Okay, the name itself eventually. I got one wrong because I two think that okay, I will get that, but one thing I got, yes, C of GCD of C comma C plus 1 is like, yeah. So if A equal to B, I hope the code is visible. Yeah. So where was I? Yeah. If A equal to B, then answer be 0. Else I run a while loop only to check how many times I need to increment. So if GCD is C plus K is 1, K is 0. Now if they are equal, so I need K number of times I incremented plus to apply the GCD operation. If K equal to 1, the number of operation required is 2. Else in all other cases, now my K would be uh, K equal to 2 after exiting this loop. K would be 2 and 2 plus 1 is 3 in all other cases. Right? This was the question. A bit of easy question. That's why many people solved it if they found this greedy approach. Right? Is it all clear? Yeah. Then we'll move on to the next question. Yeah. Okay. Let's move on to the next question. Uh, okay. So one thing I did is the split and differ. Okay. Let me first explain the problem statement. Okay. So you are given We are given an array A, here A1, A2 up to AN of length n. In this, you have to construct a array B of length. Its length must be at most 3n, right? But there are some condition B1, B2 up to Bn. But there is some condition that no Bi should be equal to must be equal to Bi plus 1. Okay, this is the first condition. Like my adjacent element must be different. Also, also, second condition is my whatever I have chosen this now. Let me write it again. A1, A2, A3, AN, and whatever I have like B1, B2, bj, then bj plus 1, bk, then bk plus 1, bl. My sum subarray of these, this sum must be equal to a1, this subarray sum must be equal to a2, and this subarray sum must be equal to a3, and so on up to an. Okay. For example, let me change the color of my pen. I have been given an array a as 7, 4, 4. Okay, like wait a minute. I think I need to enter picture in picture. Okay. Uh, what decrease the size? Yeah, right. So, for example, I have been given 774. So I can construct B as like this. I can write like 1 comma 6, 3 comma 1, and 3 comma 1. Is it valid? Is it valid from whatever you understood till now? Is it valid? It is valid. Like no element are consecutively are equal. Okay, you can see no adjacent element are equal, and also I can divide it into subarrays such that 6 plus 1 is 6, this subarray sum is 4, this subarray sum is 4 also, right? Is it clear? Right. Okay, you have to construct, and its length must be at most, if this is n equal to 3, its length must be at most 9. Okay, we have to construct an array B. Now we'll see a lot of examples, we'll see lot of edge cases. Now tell me one thing, if my array is like this, something, and I have 1 and 1, then 3, 1, 1, 3, for example. Is it possible to construct array B? Tell me. Is it
No, Bia.
possible? Because you can only write 1 is so 1. Because subarray sum, to make the subarray sum, you can take these two, and these two will eventually be equal. So it's not possible. Okay. What about 2, 1, 2? Okay, only 2. What are the ways to divide it? I can write like 2 as it is, or 1 comma 1. But my 1 comma 1 is not possible because these are equal. Okay. So single 2, if my array is single 2, I can write only like 2. But if I have consecutive 2s, is it possible to correct to construct array B? Is it possible? It is not possible. Invalid. You can write this 2 as like this, but for this 2 you can do neither of this. 1 comma 1 is not valid, and 2 is also not valid. Okay, so in these cases you have to return the -1. Else you need to first return the size of array B that you have created and return the array B. Okay, let us discuss some more examples so you will be clear. Suppose my arrays like this: 3, 3, 2, and then 3. What will be your approach like? What you guys are thinking? How can I divide to like avoid this so that I can satisfy this condition also and this condition also? What is the easiest way to divide any element A1?
1 and AI minus 1.
Okay, 1 and AI minus 1. Okay, so you are treating 1 as the divider, okay, and AI minus 1. So you are doing AI minus 1, right? Or you can do AI minus 1 1, right? And also you can write like eventually I if all elements are distinct. Okay, for this I can write 3 as 3. No worries. This subarray is length 1 and sum is 3. For this 3, what I do, I break it into 2 comma 1. For this 2, I do nothing, just like 2. And for this 3, I do like this. So this will be valid, right? What about there was a 1 here, 3 3 1 3. So this split is then invalid, right? So we had to do like this: 3, then 1 2, then 1, and then 3, right? Okay. What about this? 3 3, this is A, and this is B. Again, I write like this: 3 3 1 1. It will be invalid two consecutive ones. Not possible. What about this? A equal to what I was trying to do is 3 2. Yeah, I think 3 3 3 2 3 2. 3 2 3 2 3 2 3 3 2 3 1. Okay. What will be the approach? So I just wrote the 3 here. For 2, I can do nothing but to construct this. For 3, I can do, since these all are distinct, I can eventually write whatever is written. Okay. So if all the elements are distinct, I can return the answer as A. Okay. I have to do nothing. Right. These are some of the questions. Okay. And eventually we'll solve like this. In each case, you have to either like if these AI is less than 2, then you have to write only the AI part. You can do nothing, or else you can choose 1 comma AI minus 1, or AI minus 1 comma 1, or AI. Okay. But also while you are dividing now, you have to check once. You have to check two values, L and R. Okay, L denotes what I have chosen in B last, what value I have pushed at last, what value I have pushed last in array in B, and right denotes what is going to come in array A next. What is the next value? Right. Uh, what will be the next value? Right. So, for example, I wrote like this. Example is 7, 6, 5. Uh, it will be 6. Oh, right. 6, 5. Then I would do like again 5, then 1. Okay. So for this 6, I do 1. But for this 6, I have to divide, right? These are equal. So I can do either 1 comma 5 or 5 comma 1. This choice will be determined by this R. whatever placed here, this will guarantee me, okay, I will choose this part or this part. Okay, for this, if 5 is present, I'll choose this part. But what if there was 1 here? I wouldn't choose this to get my answer. Okay, so you have to maintain two values, L and R, so that you can effectively break this element here. So for this, I can choose this 5 1, then place 5, and again I have condition either 4 comma 1 or 1 comma 4. Since I have a 1 here, so I cannot choose this. I have to again choose this. Okay, so 1 4 and 1. Okay, so in this way I can create this. Is the approach clear? There is nothing like you have to maintain two's L and R, and you have to, on the basis of L and R, you have to like determine, okay, whatever I place 1 comma AI minus 1 or AI minus 1 comma 1, and like this. Is it clear why we took two values L and R? Okay, so when I solve this question, we'll see, when I solve this question, I had many wrong summation because I was only considering the left value, what I have chose here. Okay, I have only concerned, okay, what I have placed here in the B array, this left one. I was not considering this right value, but you have to again considering it for placing. Okay, let us look at the code. Uh, yeah, yeah. So yeah, whatever the edge cases I discussed, if two elements are equal and they are either one or two, then my construction is not possible for array B, so I will return -1. If not possible, then I'll return -1. Else I would traverse the array. Okay, so I'm keeping two pointers L and R to keep the left. L denotes the whatever the last value I pushed in array B, and right value determines the next value I'm going to get in array A. Okay, so R is AI plus 1. Okay, so if my value in AI is 2, I have no choice to put this in answer, and I like update my L as AI. Else what I do, if my AI is not equal to L and my AI is not equal to R, what I can do, I can eventually push the element itself. Okay, since these are not equal to any of this L and R. Okay, so I push this element AI and update the L value. Else, if it is equal to either of L or R, okay, now I have to check. If my L value is 1, is not equal to 1, and R value is not equal to AI minus 1, that means I can push 1 comma AI minus 1, right? So I push these two elements and update the L value here. Else, if it is like, for example, I'm encountering this condition. Yeah. So if something like this is my B array, and something like this 1 and 5, I have to divide 6. So I'm treating this condition only. So if my L is not equal to 1 and my R is not equal to A minus 1, I can push this, but here it is violating both of these, so I have to push 5 comma 1 here. Okay, so push AI 1 comma AI minus 1, update the left pointer, or else push AI minus 1 comma 1 and update the last value as 1. Okay, after you construct the array B, you have to again check if any of my adjacent element are equal, because here I had no choice to push these. Okay, so there may be some cases that after all doing this, I may get some adjacent elements equal. So I have to again check this, and if they're equal, so you can tick the flag as false. Okay, so if it is false, then answer would be -1. Else you can return the size of array and eventually print the answer. Okay, so in this way, like we can greedily divide all the elements as 1 comma ai minus 1 and ai minus 1 comma 1. Right? You all get the approach. There was nothing like any toughness in the question. Just you have to maintain LNR. Okay. Okay. Any doubts? Like whatever you may ask if you have any doubts, or else you can leave.